Hi everyone. Yeah, can you guys hear me?
Yes.
Yes.
Great. So we'll get started. Can you guys also see the screen?
Yes, we are. We can see the screen.
Yeah. So today we'll discuss a assignment that is similar to assignment 4 that you're given. Uh, so in assignment 4, yeah, you're given a table and then you're given some questions. So it will be very similar to that. So the table here is given that 3 varieties of pepper collected from different parts of India, V1, V2, V3, were planted, and each of them were given different fertilizers, F1, F2, F3, and pesticide treatments, P1, P2, P3. The eugenol content in these papers are estimated after harvesting and extraction. All the following questions are related to this data. So we are given this table. We have 9 different values for each of the combinations of, not each combinations, but for some of the combinations of the fertilizer, pesticide, and varieties. So the first question is, what is the average yield for fertilizer treatment F1? So in this question, to find the average yield, what we'll do is we'll see where all fertilizer F1 comes in the table. We'll take all the values for those 3 rows, and then we'll add them and divide by 3. That's how we get the average yield. So the answer here comes out to be 41.667. Is that clear for everyone?
Hello, just joined. Could you just repeat this, please? Sorry.
Yeah, sure. So the assignment, so the problems they are discussing is similar to assignment 4 that you are given. So the basic table that we are given is this. So we have 9 different values for 3 different kinds of fertilizer treatments, 3 different kinds of pesticide treatments, and 3 different varieties of pepper. And we are given the yield values for, we are given the yield values on the last column. Yeah. So the first question here is, what is the average yield for fertilizer treatment F1? So what we'll do is we'll see where all F1 occurs in the table. We'll take all those values, add them up, and then divide it by 3 because it occurs 3 times. So that's how we get the average yield, which comes out to be 41.667 in this case. Is that clear?
Yes, now it's clear.
Yeah. So the second question is also very similar. What is the average yield for pesticide treatment 2? We'll do the same thing. We'll take the places where pesticide treatment 2 occurs. We'll sum them up and then divide it by 3. Here again, the value comes out to be 41.667. Yeah, that's clear, right? Hello?
Yeah, clear.
Yeah. So again, the third question is also very similar. We have to calculate the average yield for ginger variety 3. We'll do the same thing. We'll take the 3 values and then average it, and we get a value of 25 in this case. Is that clear?
Yeah, clear.
So essentially, this is more to do with the. I mean, some of those lectures I'm yet to come to. That's why I was just asking. So basically, it is the yields corresponding to the use of that particular component that we have to take an average of.
Yeah, exactly.
For factorial.
Yeah.
Yeah.
So these questions are related to three-way ANOVA. All of these questions are based on that. I think it's in the last video of week 4. There's a similar example that Sarah has discussed in that video. Yeah, so in the fourth question, we are asked to find the grand average. So the grand average is given by a sum of all the data points divided by the total number of data points. So here we have 9 data points. So we sum them all up and then divide it by 9. So we get the value of 390 by 9. Yeah, which comes out to be 43.33.
Hi.
Yeah. Yeah. Is that clear?
Yes.
In the fifth question, we are asked what is the total sum of squares. So to find out the total sum of squares, what we do is we take the grand average, we subtract it from all the values, square them and add them up. So the first value here is 45. So we take 45 minus 43.3, square it, add it to 55 minus 43.33, square it, and so on. Then, yeah, so we find that the total sum of squares in this case turns out to be 2100. It's quite straightforward. Yeah. Is that clear?
Yes.
Could you just repeat that question 4? I'm not getting it.
Okay, yeah.
Question 4,
So-
some connectivity problem, I think. Yeah.
Yeah.
Some
So
of all
question,
the points you said, so all the 9 data points?
yeah, all the 9 data points.
Okay, that is the what that's termed as
Grand
a
average.
grand average. That is okay. So, and that average is what you're subtracting for the TSS, total sum
Yeah.
of squares.
Yeah.
Okay.
So grand average is the average we get by taking all the data points, adding them up and dividing it by total number of data points. Then to calculate the total sum of squares, we subtract each data point from that average, square it, and then add it. Is that clear?
Okay.
Yeah. So in the sixth question, we are asked which of these factors is significant? Fertilizer, pesticide, variety, and the fourth option is fertilizer and pesticide. So in this case, we need to calculate all the sum of squares, that is sum of squares for pesticides, sum of square for fertilizer, sum of square for varieties. We have the total sum of squares. Then we find the sum of square of errors. And then we take all the degrees of freedom for all of these values. Then find the mean sum of squares. And then the F value. And which of these has the fertilizer, pesticide, or variety, which of these has the highest F value, that we say as significant. If two of them have the same and the highest value, then we'll choose option D. So first, what we'll do is like we did for pesticide one,
Sir,
fertilizer.
can you please
Yeah, sorry.
elaborate the procedure for the question number 3?
Yeah, so here what we'll do is first we'll calculate all the sum of squares.
Sir,
So
can
you
you
guys
please
saw,
elaborate the procedure for question number 6?
yeah, I'm coming to that. So here, so in this question, we'll have a table at the end of it. We'll have a table. Okay. So for each of the factors, fertilizer, pesticide, variety, then we have the error and we have the total. So for each of these values, we'll calculate a sum of square. So here we'll calculate the sum of square of fertilizer, sum of square of pesticides, sum of squares of variety. We'll have the sum of square of errors, and we'll have the total sum of squares. Then for each of these values, we'll have a degree of freedom. So for fertilizers, since we have 3 fertilizers, the degree of freedom will be 3 minus 1, 2. For pesticides, since we have 3 pesticides, we'll have 3 minus 1, 2 again. And for varieties also, since we have 3 varieties, we'll have 3 minus 1, 2 degrees of freedom. So the total, for the total, the degrees of freedom, we take the total number of data points and we subtract 1. So the total number of data points here is 9. So here the degree of freedom for the total will be 9 minus 1, which is 8. Then for error, what we'll do is we'll subtract the sum of all these 3 from the total. So 8 minus 2 plus 2 plus 2, which is 8 minus 6, which gives us 2. So this is something we'll have. Then we'll calculate the mean sum of squares. So mean sum of squares is nothing but sum of squares divided by the degrees of freedom. So in this case, it will be SL sum of squares of fertilizers divided by 2. Here it will be sum of squares of pesticides divided by 2. It will be sum of squares of varieties divided by 2. And here it will be sum of squares of errors divided by 2. And for the final, it will be total sum of squares divided by 8. Then from these, we'll calculate the F value. So F value is given by mean sum of squares of the effects that we are considering divided by mean sum of squares of the error. So it will be mean sum of squares of fertilizers by mean sum of squares of error, mean sum of squares of pesticide divided by mean sum of square of error, and mean sum of square of varieties divided by mean sum of squares of error. So we don't need to calculate this for these two. We are just considering these three factors, and the F values that we'll get, which of these three has the highest F value, that we will say as having the most significant or is the most significant factor. Is that clear?
Yes.
Yeah. So for calculating the sum, sorry. Yeah.
Yes, sir, I understand.
Yeah, can you repeat?
Till the point you have said ki highest the value, highest will be the significance. I understand whatever you had elaborated in the question answers, sir. Thank you.
Oh, okay, yeah. So yeah, so that is what we are going to do. So to find the sum of squares, what we need to find is we need to find all the averages. So for finding the sum of squares for fertilizers, we need the average for, we need the average for fertilizer 1, we need the average for fertilizer 2, we need the average for fertilizer 3. These all will calculate similar to how we calculated these things. Right. So here we calculated the average yield for fertilizer 1. In the similar way, we'll calculate the average yield for fertilizer 2 and fertilizer 3. Then what we'll do is we'll calculate the total average for fertilizers, which will be given by average yield of fertilizer 1 plus average yield of fertilizer 2 plus average yield of fertilizer 3 divided by 3. And then we calculate the sum of square of fertilizers by the average of fertilizers minus average yield of fertilizer 1 whole square plus average yield of all fertilizers minus average yield of fertilizer 2 whole square plus average yield of fertilizers minus average yield of fertilizer 3 whole square. And then we multiply this value by 3 because we have 3 data points for each fertilizers. So here we have 3 data points for fertilizer 1, 3 for fertilizer 2, and 3 for fertilizer 3. Right. 1. Yeah. So that's why we'll multiply the whole thing by 3. That's how we get the sum of squares for fertilizers. In a similar way, we'll calculate the sum of squares for pesticides and the sum of squares for varieties. Is that clear?
Sir,
Hello?
pardon me to ask you, just to ask you,
Yeah,
please
it's fine.
repeat the question 1, 2, 3.
After this, okay, it's better if I repeat it now. Yeah. So
Yes, sir.
for question number 1, yeah. So we are asked what is the average yield for fertilizer
Sorry, is
treatment?
it better when we finish the questions and then we will start from 1 and 2? Otherwise, the continuity will not be possible, and we will be repeating 6 from 1 and then 2 from 6 and jumping here
Yeah.
and there. Will you finish in a normal stretch and then others can leave, and those who want again can get the presentation?
Yeah, because we'll use these calculations when moving forward. So I think it's better if we repeat it now. I'll just go over it
Sorry
quickly.
to interrupt. Sorry.
Yeah, yeah.
just that you are talking right now. Is it okay if I ask some question from assignment 3 after you finish this? I have
Yeah,
some
sure.
doubt there.
Yeah, sure.
Okay.
Yeah. So I'll just go over this quickly. Next time, if anyone else has a doubt in this, we'll come to it after we finish the last question. So here we are asked to calculate the average yield for fertilizer treatment 1. So we'll see where all fertilizer treatment 1 is present. So these three cases, we'll sum them up and divide it by 3. That's how we get the average for fertilizer 1. In a similar way, for question 2, we do the same thing for pesticide treatment 2. And for question number 3, we do the same thing for variety 3. Okay. Yeah. So is everyone clear
Okay, sir. I
about?
get it.
Yeah. So those three values we'll use when we are calculating the sum of squares for the fertilizers. So we'll have the average of fertilizer 1, average of fertilizer 2. Then we'll have a total average for all the fertilizers, which is the average of all these three values. And then for calculating the sum of squares, what we'll do is we'll subtract the average of fertilizer from each of these fertilizer values. We'll square them up and add them. And we'll multiply it by 3 because each of these has 3 data points. So there are 3 data points for F1, 3 for F2, and 3 for F3. So is everyone clear up to now?
Yes.
Yeah.
Yes, sir.
Yes. So as mentioned earlier, we calculate all the average values for pesticide treatments 1, 2, 3. We get these values 48.3, 41.6, and 40. We calculate the average for all the fertilizer treatments and we get the values 41.6, 43.3, and 45. Then we do the same thing for the varieties and we get these values 45, 60, and 25. Then we calculate the mean for all the pesticides, which is P1 plus P2 plus P3 means divided by 3, which turns out to be 43.3. We do that for varieties and we also get 43.3, and we do it for fertilizers and we also get 43.3. Is that clear?
Yes, yes, sir.
Yes. Yes.
Yeah. Then what we do is we calculate the sum of squares, as I mentioned earlier. For pesticides, we take the average value for all pesticides, subtract it from the yield of the first pesticide average, square it. Then for the second one and the third one, we add all the squares and we multiply it by 3. We get a value of 116.665. For sum of squares for fertilizers, we do the same thing and we get a value of 16.665. And for varieties also, we do the same thing and we get a value of 1850.001. Is this clear?
Yes.
Yes, sir.
Sir,
So
pardon me. The
yeah,
last
yeah.
session, the sir, the Muhammad sir was teaching us that for a total sum of squares, we only need to do the means. Don't need. We don't have to need multiplications. That is the last step you have done in the each formula for pesticides, for variants, and for
Yeah. Here we
variety.
are not doing the total sum of squares. No.
Okay.
The total sum of squares was this. For
Okay.
this, we just subtract it from the mean, take the square and add it.
Ah.
So for
So
each
why we
treatment,
are multiplicating by 3?
yeah, so for each treatment, when we do this, when we calculate the sum of squares for each treatment, what we do is we subtract the mean of the whole group from each of the observations and then add it. And because F1 has 3 independent observations, F2 has 3 independent observations, and F3 has 3 independent observations. Therefore, we multiply it by 3
Okay, okay,
because we have
okay.
3 values of F1, 3 values of F2, and 3 values of F3.
Okay, okay. Now I get it, sir. Thank you.
Yeah. So that's how we get the sum of squares for all of these. We know that the total sum of squares is the sum of square of error plus sum of square of all the mean effects, that is pesticides, fertilizers, and varieties. So we can rearrange this equation to get the sum of square of errors. So the sum of square of errors will be given by total sum of squares minus sum of all the sum of squares of all the effects. So we get the we had the total sum of squares from here, which is 2100. We have the sum of squares of pesticides, fertilizers, and varieties. So we'll add them all up and subtract it from 2100. So we get the sum of squares of errors as 116.679. Now we'll make the table that I had initially told about. So we have the sum of square values from all the calculations that we did. The total sum of squares is 2100. Sum of square of error is 116.679. Sum of squares for varieties is 1850.001. Sum of square of fertilizer is 16.665, and sum of square of pesticide is 116.665. The degrees of freedom we calculated earlier, since we have three observations for pesticides or three types of pesticides, the degrees of freedom here is 3 minus 1, which is 2. Similarly, for fertilizers, we have three types of fertilizers. So the degrees of freedom is 3 minus 1, 2 again. And for varieties, since we have three varieties, the degrees of freedom is 3 minus 1, 2. The degrees for total sum of squares will be the total number of data points, that is 9 minus 1, which is 8. Then to calculate the degrees of freedom for error, what we'll do is we'll take the total and we'll subtract the sum of these three, as we did here to get the sum of square of errors. So we'll have 8 minus 2 plus 2 plus 2, which is 8 minus 6, which is again 2. Then we'll calculate the mean sum of squares, which is nothing but the sum of squares divided by the degrees of freedom. So for pesticides, we have mean sum of squares is 58.3275. For fertilizers, it's 8.3325. For varieties, it's 925. And for error, it's 58.3395. Then to calculate the F value, we just need the F value for the mean effects, that is the pesticides, fertilizers, and varieties. So what we'll do is we'll divide the mean sum of squares of pesticides by the mean sum of square of error. That gives us a value of 0.99, which is approximated as 1. Then for fertilizers, we divide the value again by the mean sum of square of error, which gives us a value of 0.1428. And for varieties, we again do the same and we get a value of 15.855, which is approximately 16. Of the three factors, we see that 16 is the highest number that we get. So we say that of the three factors, variety is the most significant factor. So the answer here will be C or D. Is this clear?
Sir, so more the F value.
Yes, clear.
Yeah.
Hello.
Yeah.
Hello, sir. So more the F value means it is more significant.
Yes.
Okay, sir. Sir, in TSS, how we got this value 2100?
So TSS we calculated here. So what we did was we got the grand average, which is nothing but the average of all the data points, which turns out to be 43.33. Then we subtract each data point from the average and square it and then add it.
Okay, sir. So back to that question slide.
Yeah. Which question?
Next slide, sir. Next slide. Last slide.
Okay, yeah.
TSS. Sir, and this SSB okay, and SSB got divided by degree of freedom.
Yeah, you get the mean sum of squares.
Okay, sir, and you have written there one formula TSS equals to SS on the right corner.
Yeah.
Okay,
so
that is for this.
Yeah. That is the main formula. So total sum of squares is sum of squares of error plus sum of square due to each factors. So from this formula, we get this formula.
Okay.
We just take all of this to this side.
Okay, sir. So and last step, no need to divide 2100 by 8.
No, that's not needed. Yeah.
Okay, sir. Understood.
We just need the mean sum of squares for these four things.
Yes, sir. Thank you very much.
Yes.
Sir, if we do it, sir, if we divide it by 8, just to for the last point, what will be it means, मतलब आप इसको क्या रिफ्लेक्ट कर सकते हो, इससे क्या रिफ्लेक्ट हो रहा है कि by dividing 2100 by 8 what will be reflection, मतलब हमें आंसर जो मिलेगा उसका क्या मीनिंग है, सिग्निफिकेंस है?
Uska, for any of our purposes, there is no significance, so that's why I left it out. So these three effects are the effects that we are seeing. We want to find if pesticide treatment, fertilizer treatment, or variety is a significant value, which gives us a difference. We calculate the mean sum of squares for error because to calculate the F value, we divide all of these three by this one. So, but for the total sum of squares, even if we get this value, we won't use it. So that's why I didn't calculate it. So here, basically what we are trying to do is, we are trying to see the variance due to pesticide, the variance due to fertilizer, and the variance due to variety. And then we have a variance due to error or random effects. We are trying to see if the variance of the pesticide, fertilizer, or variety is larger compared to the variance due to error, like random effects. So if this part, like any of these ratios is quite large, that means that the effect of the variety on variance is quite large compared to the random effect. That's why variety is a significant factor.
I think
So the higher the F ratio, the more significant will be the factor.
I think the TSS divided by the total TSS divided by the total number of degrees of freedom would have been termed as the
Mean sum of squares, total mean sum of squares.
Isn't it?
Yeah.
In case that had been asked as a question, that would have also featured, I guess. That calculation also.
So if we do this 2100 by 8, what this gives us is the variance for the whole data set.
Variance for the whole data set. So that's termed as the mean variance, it will be.
Mean variance, yeah, exactly. Mean sum of squares, mean variance, yeah. So, yeah, but for our purposes, we won't use it anywhere, so we have left it.
It will come as a question,
Yeah.
Sir, this calculated F value need not check with the table F value, the final. So we have calculated.
Since in the question we are not asked for any confidence levels or anything, so yeah.
Okay.
We just have to report which of these is the highest. Yeah.
Significant. Okay. Thank you.
So if the question was like, which of these factors is significant at 95% confidence level or something, then we would have looked at the table.
Okay. Thank you, sir. Thank you.
Does anyone else have any questions?
Yes, sir. I have a question from assignment 3 itself.
Assignment 3, just a second.
Yes, sir. I also have the same.
Okay. Just open the assignment. Which question is it?
Sir, the first one, it says,
yes, this first.
Yeah, may I just open the?
Yeah, read out the question.
So the is I just want to know that the T calculated is 2.34 what we got, okay, and for two-sided like for double tail means two-tail test, the T value is less than the like the calculated is less than the table value. So here we where is it? So here we accept the null hypothesis, right?
Yes. So since the options are given, new drug is better, new drug is worse.
Yeah.
So you can do a one-tail test. So sometimes what happens is because the t-values, critical t-values for one-tail test and two-tail test are different. Sometimes you will get a value in between which will pass the one-tail test, but it will fail the two-tail test. So since two of these options are new drug is better, new drug is worse, and if you are getting an answer for one tail test that says that new drug is better, then it's better to choose that option.
So, what would have been the answer if I for case where it says new drug is worse?
New drug is worse. So you will say new drug is not worse. So new drug is actually better.
Sir, but in the last session, when sir was assisting us, he told that the option for both are equal is the correct answer.
Both are equal won't be correct
So
because you
why?
passed the t-test, no?
Because he said ki the
Yes,
value.
sir. I too have the same.
Yes, sir. Because in the last session, Mohammed sir has assisted us कि the value of P doesn't have any effect on the any of the drugs, so you don't need to calculate the T value of any kind of tail test, two tail test or
Yeah.
one tail test. You only need that, and there is no effect of the value given like P on the drug effect. So you need to
Yes.
check it and do it like both are equal. He told us like that. So I don't know why the answer sheet
Could
is
you
saying that new drug is better.
Yeah. I
could
same
you
problem.
could
I
you
also.
repeat that part? I could not understand.
Sir, in the
So
last session,
what did he say? Yeah,
in the last session when sir was assisting us, he said ki
yeah.
P value, the value of P given in the question doesn't have any effect on the drug. You don't need to calculate neither of the test. You only see both are equal because he's then in this question it is saying कि p value ये पता कर रहा है. तो आप अगर आपको ऐसा दिख रहा है कि there is a p value, on that basis of p value you can't judge the drugs quality. So you only need to write that both are equal,
Yeah.
either down or they
Hello.
goes upward or better. The answer will be both are equal because no drug will be worse or no drug will be better in terms of p value when there is a p value given in the question. So you don't need to check any of the test. In that case you only see the p value, and there is no dependence कि p value पे कोई चीज depend है. You only write down कि both are equal, क्योंकि वो वर्स भी हो सकते हैं बेटर भी हो सकते हैं ड्रग. तो अगर आपको p वैल्यू दी है तो आपको both are equal पे जाना चाहिए.
Yeah, and if we are doing double tail test, and if it's if it's accept the null hypothesis, then why would I go for single tail and test again? You got my question, or you got
Yeah,
confused?
that question I get, but I still don't understand the p-value thing because, like,
So
the way I see it, you are
sorry,
given
hello.
yeah,
Hello,
yeah,
sir.
yeah.
So the p-value explanation was for question number 2. The explanation given by Mohammed sir, that was for question number 2. I think so.
No. P value for question number 2 is different. For question number first he clearly said कि अगर यहाँ पे p value का कोई काम नहीं है, ये drugs worse भी जा सकती हैं और better भी जा सकती हैं. तो अगर आपको इस तरह से question दिया है तो आपको
I think
logically
that explanation was for question number 2.
Yes, because the same explanation was given
That
by
makes more
you
sense.
in the previous session.
I think what I have here is that, the calculated answer comes as 2.35. The T calculated value is coming as 2.35 and T table value is working out to 2.015 for one tail. As it happens, this is one of those questions where two-tailed is giving a higher value. So our calculated value actually fell between. That's why the confusion arose. I think I mentioned this, in fact, when we were discussing in earlier instance. And then
Yeah.
you had mentioned since they have gone by the one-tailed thing as to whether the new drug is better, and that is given as an option, going for that, since there seems to be some difference. That way, that was your rationale. So I went by that rationale.
There is an option given,
Yeah.
cannot judge. So that should be appropriate, in my opinion.
Yeah, I was wondering about that as well, but then
It's that we need more data to confirm.
Sir,
Yeah.
excuse
that
me,
should be
hello?
the case.
But in
Yeah.
this case, when you are doing a two-tailed test, your null hypothesis is not rejected anyway, right?
Yeah. Mhm.
So then I will conclude that both drug are equal, right?
Yeah. I think the answer should be cannot judge instead of these, because
Yes,
it falls
sir.
somewhere
The
in the
same
middle. No.
problem, even I had to encounter the same problem, sir. It was just contradictory to the explanation given in the problem solving session. Maybe, sir, it may be possible ki sir has not given us the proper explanation. So from your end, please explain this question to us. All of us are actually
Yes, sir, please.
clearly confused with the options given actually.
And please
Yes,
please explain कि अगर न्यू ड्रग बेटर होता तो क्या होता या वर्स होता तो क्या होता, please.
Yes, sir, definitely.
Okay. Yeah. So.
Right.
Uh,
Clarification.
yeah. So
Minutes,
better
sir.
or worse would. Sorry. Yeah.
Hello.
Yeah.
Sir. Hello.
Hello. Yeah. Continue.
I just posted a question on the discussion forum because it is mentioned in question 1 assignment 3 as the difference in the reduction in weight between the old and the new drug, not difference in the weight between the old and the new drug. So when it is mentioned as the difference in the reduction in weight,
Yeah. I know. It should be old minus new.
T-tail value is less than the T
I
calc
think
value.
I answered the question.
According to the one tail value, the old drug is better than.
Just a second. Yeah. I didn't read it correctly, I think. Yeah. Yeah, I'll talk to them. Either the answer should be cannot judge or that the new drug is worse, as you pointed out. Great.
But I received a wrong answer reply when I checked my answer sheet.
Just a second. I think I answered that question.
I had mentioned it as cannot judge. In my opinion, cannot judge is the right answer.
Yeah. I'll raise it up to the instructor. Yeah. I also think like cannot judge should be the answer here because it's falling in between both of them. So for the purpose of the course, whenever you get a significant result, even for a one-tail test or a two-tail test, like if you get a significant result for a one-tail test but not for a two-tail test, they prefer if you go with the significant result. That's why I think they have written this, but due to the wording here, as you pointed out, this difference seems to be the difference between the old drug minus the new drug, in which case this should not be the answer, right? It should be new drug is worse. Even with the one-tail test.
Even with the one-tail test.
Yeah. I'll talk to the instructor, yeah. I also think the answer should be cannot judge. And as someone was pointing out about the p-values, I think that explanation sir might have given for the second question because it makes more sense there.
That is for the second question, sir.
Yeah.
P-value question is
So here you don't need to look at p-values because we are comparing two drugs tested in two different trials. So we don't need to look at the p-values. But for the first question, like we need to test it at the p-value of 0.05 or like 95% confidence.
Yes.
Yeah.
Sir, there is one more doubt regarding assignment 3. For one of the answers was it was given as 1.66, but what I got was 1.655. But it was a 3-mark question and I got it wrong. The answer I got was 1.655 and I typed it 1.655, but they gave that the answer was wrong. It was 1.66. So when it is rounded, it becomes 1.66. That is okay, but the whole 3 points, I lost the whole 3 points just because of that rounding up.
Same thing happened to me. Yeah.
Yeah, the same thing is happened to me also.
So that
the same thing is happened to me also.
Sir, because we are losing whole 3 points because of the mismatch in rounding up. We got it 1.655, but it was given wrong, and when the answer came up, it was 1.66. So how can it make a difference? And there was no instruction given to round it up to 2 decimals.
So generally,
there is no
kind of an answer.
Instruction.
Yeah, generally they have a range kind of answer. I don't know why they don't have it for this.
This
Okay, this also
it wouldn't have been a problem. If there were options, it wouldn't have been a problem, but we have to type the answer. No? Just because of this rounding, and the question was of 3 marks point value. So the whole mark was gone.
Yeah, okay.
Exactly. There is no instruction for rounding off.
Yeah. Yeah. Yeah.
This is the only wrong answer I get.
So generally for these kinds of questions, they have a range kind of an answer. So even if you don't round it up, you get the right mark. I don't know why they have a single answer for this. I will talk to them for this also. Yeah. Yeah, I'll talk to them about this. Question number 1 and 4. Do you have any other doubts in this assignment 3?
Sir, in question number 1.
Yeah.
Sir, it's not loaded. Hello. So can you move to question number 1?
Question number 1, right here.
Oh, yes, same assignment. Sir, using the understanding the question that we are testing the effect of a new drug to reduce the body weight of rats with reference to an existing drug using same rats. So does this question justifies that we have to check with 2-tailed or a 1-tailed t-test level of significance?
No. So this statement all it tells you is you have to use a paired t-test.
Okay, for
so
calculations.
If you would have chosen two different, like if you would have tested both the drugs in two different populations of rats, then you would have used a 2-sample t-test. But since you are using the same rats, you have to use a paired t-test. It does not tell you if you need a 1-tail test or a 2-tail test.
Okay, sir. Got it.
Sir, one more doubt regarding the last question. The same, I don't know whether others encountered it. That is, the explanation was given like that. But my question is, how can it be considered as a 1-tailed? You had given the explanation in the last problem-solving session, but it was taken as, there you considered the 1-tailed value. But my question is, how can it be 1-tailed in the last question of assignment 3?
So if first question of assignment 3, right?
Last question of assignment 3. Week 3 assignment, last question.
Yes, same question I also have. And addition to that, like how can I say that PCL is better than PLA? Like, yeah, if you could just explain.
In this case, like the t value that you get is 1.97, right? Which should be greater than both the t values for two-tailed test and one-tailed test. So for two-tailed test, the t value will be 1.86. For one-tail, I think it will be 1.64 or something. So this t calculated will be greater than the t critical value in both the cases.
Okay, sir. Maybe it was a problem with my calculation because I just got a value in between. Maybe it was because of the mistake I made in my calculation. I'm sorry. But will those two questions be reconsidered, sir? One and the other one, 1.66 answer.
Yeah. In
That be
question number 1, it comes somewhere in between. Yeah. I don't think here it comes somewhere in between. I haven't calculated it, but according to the solutions they gave, it's coming greater than both the two-tail and one-tail value, right?
Sir, whether I don't know whether others had this problem because in the last question also I had the same problem. Maybe because of the mistake in my calculation, I got a value in between, and I was wondering how it can be one-tailed.
Yeah.
So,
Good.
thinks the
Can just check your calculations later. Sorry?
Sir?
7, which is calculated value is 7 for question 6, which is much greater than
Calculated
1.
value.
Yes. Calculated value is 7. 7.0.
Calculated value is 1.97.
1.97 for question number 6.
No, for question 6, it is much higher. It is much higher than two-tail and one-tail value.
It's much higher than both. No, yeah.
So I don't.
Then it should not be.
Sir?
Yeah.
So the t calculated here is 1.97, and for two-tail, the table value it says 1.86. So here, how do you say that PCL is better than PLA just by calculating the mean? If the mean, if other way around, we would have say other way around then.
So you also check for the one-tailed test, no? So you get the difference between PCL and PLA. Using the two-tail test, you find that there is a difference because the t value is greater than 1.8. Then you check for one-tail test and you see that it's also greater. And since you're subtracting the value of PCL from PLA, you know the direction is like PCL is better than PLA.
Okay.
Sir, if suppose the answer was in between, which one would we take? Suppose
For the purposes of the course, they have chosen to take the value that is significant. So while giving out the solution for the first question here, you can see in the solution, so they have calculated both the t values for two-tailed and one-tailed test. And because the one-tailed is significant, they have told new drug is better. But ideally, you can't tell if the value comes from somewhere in between, you can't tell whether it's good or bad. You need to collect more data points. So the first question I will talk to them about, I think the answer should be cannot judge.
And more importantly, that 1.65 also. 1.65, that was 1.65 and 1.66, that question, because that's very close. 1.65, that answer we got, I think it's question number 4 perhaps, right?
Question number 4. Okay.
On assignment.
Question number 4 is means of most space, right?
Scroll down. Yeah, where we got 1.65 and it had to be rounded off. That range, if
Yeah,
it's
yeah.
considered, it will
Yeah,
be
they should have put a range here.
yeah.
Yeah. They generally put a range. Yeah. I think they have missed it. I'll notify them about this also.
Also, sir, for this issue, we can they give a weekly feedback after the submission, so we can give our comments there
Yeah.
for
So
these ranges. Yes, so it would be we would as soon as possible.
did you guys fill the form?
I'm filling for every week if I'm facing any problem. So if all are facing this range one problem, so we can go and write our comments there.
Yeah, that's a nice idea. You guys can write your comments in the feedback form. I'll try to mail them directly regarding the same also.
Of course, I filled the form prior to these answers, so I didn't expect this decimal issue to crop up. So I hadn't mentioned it then. I don't know if I can go back and mention it now.
I think you should be able to. You can try it once. Anyways, I'll write a mail to them. Yeah.
Edit your response. I think perhaps there's an option.
Yeah.
In case everyone has finished with the discussion on assignment 3, I just request that assignment 4, just once, if you could just go over the solution.
Yes, sir, go through it.
Once, just, not the
Week
6
4 last time.
but 1 to 5, you could just see it. So there were some connection issues.
Yeah, for all the questions, right?
Yeah, just to go over the working of it.
So, yeah, in the question we are given a table. We have 9 values. We have 3 kinds of fertilizers, 3 kinds of pesticides, and 3 kinds of varieties of crops. And we are given the yield values for this molecule. Yeah. So the first question is, what is the average yield for fertilizer treatment F1? So wherever we find F1, which is in the first 3 rows, we take the yield values for that and we take the average and we get a value of 41.6. We do the same thing for the second and third question. Here we calculate the average yield for pesticide treatment P2. So wherever we have P2, we take the yield values and we average them. And for question number 3, we do the same thing with the variety. Wherever we have V3, we take the values and we average them. For question number 4, we are asked what is the grand average. So the grand average is the average of the whole data set. So for this, we take all the values, we sum them up, and we divide it by total number of data points that we have, which is 9 in this case. And this comes out to be 43.33. Okay. Then for total sum of squares, what we need to do is we subtract each data point from the grand average, we square it, and we add all of these things to get the total sum of squares. Are these questions clear?
Yes, sir.
Yes.
Yeah. So for the last question, we are asked.
So sum of squares, there's no okay. Unlike SSF is the one where there is a multiplication because they are independent trials.
Multiplication,
so sum of squares is just the sum of the differences, squared differences. Okay. Yeah.
Yeah. So this is the sum of squared differences of all the data points. So we don't have anything else left to multiply because we are using everything. Right. Yeah. So the sixth question is, which factor is significant? For this, we need to build the ANOVA table. Okay. So for each of these factors, fertilizer, pesticide, and variety, we need to calculate the sum of squares. We also need to calculate sum of square of error and the total sum of squares. We get the degrees of freedom. So for each of these 3 cases, it will be 2 because we have 3 varieties of fertilizers, 3 varieties of pesticides, and 3 varieties of varieties. Yeah. So it will be 3 minus 1, 2. The total sum of squares will be total number of data points minus 1, which is 9 minus 1, 8. And for error, we'll calculate it as 8 minus 2 plus 2 plus 2, which is 8 minus 6, which is 2. Then we need to calculate the mean sum of squares. For all of these values, the mean sum of square is sum of square divided by degrees of freedom. Okay. And then for the first 3 factors, we need to get the F value, which tells us about the significance, and which of these has the highest F value. Since we are not given a confidence interval to calculate here, which of these has the highest F value will be stated as being the most significant factor. So for calculating the F value, what we do is we divide the mean sum of square of each of these factors by the mean sum of square of the error. Then to calculate the sum of squares for each of these factors, we need the mean yields for each of the varieties of fertilizers that we have for calculating sum of square of fertilizers. We need F1 mean, F2 mean, F3 mean, which we can calculate as we did in the previous questions, question 1, 2, 3. Then we need the average mean for all the fertilizers, which we get by adding these 3 and divided by 3. Then to calculate the sum of squares, what we do is we take the mean of the fertilizers, we subtract it from F1, we square it, we take the mean, subtract it from F2, square it, and do the same for F3. Then add all of these together and then multiply it by 3. So this multiplication by 3 we are doing because F1 here has 3 different values, F2 has 3 different values, and F3 has 3 different values. So since we are just taking this term once, so basically what we need to do is for each of these 9 terms. So for first case, we need to take F minus F1 mean of F minus mean of F1. We need to square it. For this case, we take mean of F minus mean of F1 square it, mean of F minus mean of F1 square it, then mean of F minus mean of F2 square it, then the same F2, then mean of F minus mean of F3, F minus F3, F minus F3, and we add all of these 9 terms together. That's how we get the sum of squares for the fertilizers. Since these 3 values, like for these 3 values, we just take the mean of F1. So that's why we are just doing this whole thing once and then multiply it by 3.
Fine.
Okay, so for sum of squares, we need to calculate it for all the data points again. But because in the first 3 cases, what we are doing is F minus F1 mean whole square. Here again, F minus F1 mean whole square. Again, F minus F1 mean whole square. Then F minus F2 mean whole square and so on. And we add them up. So these terms are repeated 3 times. This term is also repeated 3 times, and this is also repeated 3 times. So instead of just adding it up 9 times, we are just adding these 3 and then multiplying it by 3. Is that clear?
Yes.
Yeah. So now we do all the calculations. So we calculate the average yields for pesticides P1, P2, P3, fertilizer F1, F2, F3, and varieties V1, V2, V3. Then we calculate the average for all the pesticides, all the varieties, and all the fertilizers. Then we put the formula that we had here for all 3 of them. Then we get the sum of squares for all 3 of them. Here, using this formula, so total sum of square is equal to sum of square of error plus sum of squares of all the factors. So from this formula, we can calculate the sum of square of error by just bringing all these terms to this side. So we get the sum of square of errors. Then we build the table that we initially had. So we have the sum of squares that we calculated, the degrees of freedom that we know. Then we find the mean sum of squares, which is this divided by the degrees of freedom, sum of squares divided by degrees of freedom. We calculate it for the first 4. we don't need to calculate it for the total sum of squares, but it will give us the mean variance, which is the variance for the whole data set. Right. Then we need to calculate the F value, which is mean sum of squares by mean sum of square of error. So we divide each of these terms by the mean sum of square of the error. And then we get the F value. We see that the F value for variety is the highest. Therefore, of the three factors, we say that variety is the most significant factor. Is that clear?
Sir, for SSC,
Yeah.
how could the degree of freedom could be 2?
For SS? Sorry,
SSE,
could you repeat?
Error.
SSE,
SSE,
okay.
error.
Yeah. So for SSP, we have degrees of freedom 3 minus 1 because we have three kinds of pesticides. Right.
Nahin, sir,
Again, for SSF, we
sir,
have 3 minus 1. Yeah, I'm coming to it. For SSF, again, we have 3 minus 1, which is 2. For SSV, we have 3 minus 1, again, which is 2. For total sum of squares, we have degrees of freedom n minus 1, where n is the total number of data points. So we have 8. And for calculating the sum degrees of freedom for error, what we do is degrees of freedom total minus degrees of freedom pesticide plus degrees of freedom variety plus degrees of freedom fertilizer. So we have 8 minus 2 plus 2 plus 2, which is 8 minus 6, which is 2. It's basically like we are calculating the sum of square of error. So instead of this equation, we just have the degrees of freedom. Is that clear?
जैसे नहीं सर, जैसे P वैल्यू है तो P1 3 है, P2 भी 3 है, P3 भी 3 है, तो ये कैसे डिसाइड कर रहे हैं कि हम 3 minus 1 ही करना है, हमें 9 minus 1 नहीं करना है?
So for this whole thing, so this is the total sum of squares. This is the sum of all these. Okay. So the sum of squares, all of these, if you add, you will get 2100. Similarly, for total sum of squares, the degrees of freedom that we get will be the sum of all of these. So in one way ANOVA, it's quite easy to understand how to calculate this because you have a small data set and you just have one factor. In two-way ANOVA also, you just have two factors. But when you get to three-way ANOVA or multivariate ANOVA, it gets difficult how to calculate the SSE directly. So what we do is we calculate the degrees of freedom of all the other things. And then from the total, we subtract to get this.
सर
Since
नहीं
we
सर,
know that the total will be the
मेरा
sum of this.
सर मेरा क्वेश्चन ये है कि जैसे हमारे पास वेरिएंस 3 है, V1 V2 V3, तो अब V1 के भी 3 अलग अलग वैल्यूज हैं, V2 की भी 3 अलग अलग वैल्यूज हैं, V3 की भी 3 अलग अलग वैल्यूज हैं। तो अगर हम वेरिएंस के लिए डिग्री ऑफ फ्रीडम निकाल रहे हैं तो हम 3 minus 1 पे क्यों जा रहे हैं 9 minus 1 की जगह पे? इंस्टेड ऑफ 9 minus 1 व्हाई वी आर टेकिंग 3 minus 1? What is the logic behind it?
For this one, for the degrees of freedom of variety. हेलो,
किसी भी लिए ले लीजिए ना सर आप, क्योंकि जो हमारा ये है ये फर्टिलाइजर है, वेरिएंस है, सारे ही F1 की भी 3 वैल्यूज हैं, F2 की भी 3 वैल्यूज हैं, F3 की भी 3 वैल्यूज हैं, उसी तरह वेरिएंस की भी V1 V2 की V3 की और P1 P2 P3 एवरीवन हैज 3 डिफरेंट वैल्यूज। तो हम जो डिग्री ऑफ फ्रीडम निकाल रहे हैं वो हम n-1 पे चलते हैं, तो वहां हम 9 minus 1 क्यों नहीं कर रहे हैं, 3 minus 1 क्यों कर रहे हैं?
हाँ, ओके। सो हाँ, हम 3 minus 1 कर रहे हैं क्योंकि हमारे पास the number of different kinds of varieties or the number of different kinds of fertilizers 3 है. So that's why we are doing it 3 minus 1.
पर
not n minus 1.
वैल्यू अलग अलग है ना हर जगह, तो उनकी लास्ट वैल्यू देखिए सर, V1 के लिए 3 अलग वैल्यू है, V2 के लिए अलग वैल्यू है, V3 के लिए अलग वैल्यू है, 3 अलग अलग वैल्यूज आ रही ना सर।
तो कौन सा अलग अलग? यहाँ पे हेलो, अलग अलग वैल्यूज मतलब व्हाट डू यू मीन एग्जैक्टली?
एग्जैक्टली सर, जैसे F1 है उसके लिए जिंजोरियल वैल्यू एक 45 है, एक 55 है, एक 25 है। F2 के लिए भी 70, 20, 40, F3 के लिए 30, 50, 55। तो जब हम इनका
अच्छा
डिग्री
वैसे,
ऑफ डाल रहे हैं
हाँ
उस केस में डिग्री ऑफ फ्रीडम, तो why we are not going like 9 minus 1, why we are taking 3 minus 1?
हाँ, see, so when you are calculating the degree of freedom for the total data set, you take the whole thing because you are treating everything as independent observations. ठीक
Okay
है,
sir.
इसीलिए we are taking 9 minus 1 for total number of total degrees of freedom. But in the case of fertilizers, you have 3 groups of fertilizers, F1, F2, F3. So even if the values that you get here are different, they are in some way related to each other. They are not independent of each other. All these 3 values are coming because we are using F1.
Okay.
So these 3 values are treated as one value, one group of values. Similarly, F2 के लिए these 3 values are treated as one group of values. And F3 के लिए these 3 values are treated as one group of values. We have 3 groups of values. So उसके लिए उसका degree of freedom 3 minus 1 होगा.
Okay
The
sir.
degree of freedom is like the number of independent observations that you have minus 1. For fertilizers, we just have 3 different independent observations because these 3 independent, like these first 3 observations are not really independent observations. They are because of some effect of F1 on the crop. Right.
Okay sir.
Uh,
But for sir, I'm little bit, ma'am, literally sir, I'm very confused in that because F1 का अगर आप एक सेट आप ग्रुप ऑफ वैल्यूज बोल रहे हैं, तो F1 की भी तो इंडिविजुअल जिंजरोल के केस में 3 वैल्यूज अलग अलग है, डिफरेंट, और F2 के लिए भी 3 अलग अलग वैल्यूज आ रही है, F3 के लिए भी। तो हम इसको कैसे एक ग्रुप में कैटेगराइज कर सकते हैं?
So ये जो अलग अलग values आ रहे हैं, they are not only because of F1. There are different pesticides and varieties that can lead to changes in these values. So
They
ये
have
45 we can't say this is, हाँ,
and
so F1 का कुछ इफेक्ट है, उसके वजह से कुछ आ रहा है, P1 का कुछ इफेक्ट है, V1 का कुछ इफेक्ट है, तीनों मिला के 45 आ रहा है.
okay sir.
Just because 45, 55 and 25 are different, we can't say कि these 3 are different values. These
Okay.
might be just because F1 is interacting with these two differently and these two differently.
सर
Right?
ओके सर. सर अगर एक और
हाँ.
क्वेश्चन, अगर जैसे ये कुछ क्वेश्चन पुट अप किया जाए कि अगर आप फॉर द केस ऑफ F1, तो इस केस में
हाँ.
मतलब ये फर्स्ट सेकंड थर्ड जो तीनों कॉलम्स है, इनमें से बेटर परफॉर्मेंस किसका है, तो ये हम कैसे जज करेंगे? मतलब जो कॉम्बिनेशन है, विच
वो
वन इज कॉम्बिनेशन, जैसे F1 P1 V1 या F1 P2 V2 या F1 P3 V3, विच कॉम्बिनेशन इज द बेस्ट? अगर हमें इन तीनों में ऊपर की 3 लाइंस में ही देखना हो और ये मतलब आंसर देना हो कि इनमें से बेस्ट कौन सा है, तो हम कैसे बताएंगे?
3 डेटा पॉइंट्स में वो बताना मुश्किल है. Because you just have one data point for all of. So what you're saying is you have 3 cases, F1 P1 V1, F1 P2 V2, F1 P3 V3.
जी सर.
For all of these things, you just have one value each, 45, 55 and 25.
जी सर.
From these, you can't tell which one of them is better. So you need to repeat the experiment. So if you have lots of values for, let's say, इसका बहुत सारा value है 45, 47.
अगर ये 9 की 9 पूरी एंटायर टेबल को हम एक लेके चलें कि एंटायर टीम में विच कॉम्बिनेशन इज द बेस्ट, तो ये रिजल्ट हम कैसे देंगे सर?
हाँ वो भी नहीं दे सकते इससे, because you don't have enough data points for each of these combinations. You just have one data point.
हाँ, okay sir.
So it's difficult to say. So in that case, what you can do is you can collect more data. So I'll explain it here. ये छोटे वाले में. So
Okay sir.
let's say you have values like this. Okay.
जी sir.
You repeat the experiment 4 times, you get these values.
Okay.
Then what you do is you treat this as 1, you treat this as treatment 2, you treat this as treatment 3, and you have these different values. Then you run ANOVA between these 3 things.
Okay.
Or you run a paired t-test between these 2 and these 2. And then you figure out which one of them is better. But if you want to compare across the table for all the 9 values, you have more values for each of these. Then you treat all of them as 9 different treatments.
Okay.
And then you do the ANOVA on that.
Okay. Okay. Okay.
Given this data, you can't say.
जैसे सर आपने ऊपर छोटे वाले में किया है, तो पर्टिकुलर एक एक कॉम्बिनेशन के आपने 4 टेस्ट लगाए और उनकी 4 अलग अलग डिफरेंट वैल्यूज आई, तो ऑन दैट बेसिस अगर हमने सारे ही जितने भी 9 मतलब पॉइंट्स हैं, 9 कॉम्बिनेशंस हैं, इन 9 कॉम्बिनेशंस के 4 और मोर for every data we need to test it 4 or more times for each and every combination of fertilizer pesticide
4
variant.
nahi, as many as you can.
Okay, मतलब more than
Yeah.
4 or many as we can, तब हम on that basis ANOVA से फिर result declare कर सकते हैं कि which one is better.
But then you have to treat all of them as 9 independent values, like 9 independent treatments.
Okay.
Here we are comparing between different factors, if fertilizer, pesticide, and variety. In that case, you can't do that. You have to consider this as 1, this as 2, 3, 4, as each combination needs to be a different treatment.
Okay. Okay, sir.
Just one suggestion about this NPTEL submission, of assignments. If it were possible to communicate to them that instead of multiple submissions, if there was any facility to save and, the whatever you can answer today, enter the correct answers today, we enter the correct answers, and later, come back to those questions which we haven't answered today. If such an option was there, it would be very helpful. Like instead of multiple submissions.
Yeah. So you can write to them regarding this. That is something that we don't really manage, but the thing is, it's quite a big platform and it's difficult for them to make these changes as easily as you think.
Okay.
So you can just write to them and maybe they will.
As part of the feedback?
Sorry?
As part of the feedback, is it?
Yeah, as part of the feedback you can write.
Okay.
I think in NPTEL you might find email IDs of people you can contact also.
That I'm not too sure. Because if, I mean, then you know what you have entered, and that provision is there to save your correct answers instead of returning to it once again and that kind of thing.
Yeah.
I think this may be a little, as you said, complex perhaps. Anyway, from my side, I'm clear with the approach for these problems. Thanks so much, Dr. Arpit.
You can mail them at support@nptel.iitm.ac.in. I'll put that in chat.
Support at the rate of NPTEL IIT. Okay, that's.
Yeah, I'll put it in chat. Yeah.
Okay.
Also, you can fill it in the feedback.
iitm.ac.in. Thanks so much.
Sorry?
Yeah, thank you. Got it.
Yeah, thanks.
Thank you, sir. Thank you very much.
Yeah. Thanks. We will
Thank you so much.
close it today. We'll meet next Saturday. Yeah, thanks. Sure.
Excuse me, sir.
Yeah.
Yeah, I had a question. So I wrote it
Yeah,
in the
yeah,
chat.
sure.
I don't know if you've got it, but yeah, so I had a doubt with the last question of assignment 3.
If you use one-way ANOVA,
Yeah.
the F value is lesser than the table value, hence we can't put it either. How do we just the t-test more importance here? So as they have mentioned, you can use one-way ANOVA, but it will give you a different result that they have mentioned initially. But yeah, in general, if you are comparing two things, try to prefer like t-test instead of one-way ANOVA, because most of the questions they'll go for simpler tests. That's the main reason. Apart from that, I don't think there's any other reason.
Okay.
So if
So
you have like multiple things, then ANOVA makes a lot more sense, like two-way ANOVA and all.
yeah.
That makes a lot more sense. But for comparing two samples, it's much better and simpler to use t-test.
Okay. So what does it say about our result? So in this case, we can say that our result is significant with the t-test, but we can't with one-way ANOVA. So does that make
Yeah,
our
so
result less significant overall?
that is the issue with statistics. You can use a lot of complicated tests and get results that are significant when they should not be significant, and
Okay.
vice versa. So that's kind of a gray area.
All right.
But yeah, if possible at all, whenever you are analyzing something, go for simpler tests, and like also check like if the assumptions of what you are uh, trying to test, like t-test has different assumptions than ANOVA, right? T-test needs, I think, normally distributed. Not normally distributed, yeah. Z-test needs normally distributed data and all. T-test where the variance should be equal in like simple t-tests. There is test for unequal variance. But in ANOVA, it does not have such like assumptions. So whenever you are using any kind of test in your day-to-day life, try to see if your data really holds to those assumptions first, and then try to use any test. And wherever possible, go for simpler tests.
Yes, actually, in that last problem, in fact, the t-test, I did one-way ANOVA, and then I just did the t-test using Excel. I found that according to the t-test, there is a significance between the two, but according to the one-way ANOVA, it was showing as not significant. There was a contradiction in that as well. So
For the purpose of the course, from whatever I understand, for these confusions like one-tail test, two-tail test, or t-test or ANOVA, what they do is they calculate everything and see whatever is significant and try to use that. That is the thing that I get. Because sometimes it's not that clear, but they have used a one-tail test or a t-test over something else. So that is what I have the like notion. That is what they are doing. But whenever you use it in real life, you should be kind of careful. Be sure what you are using and why you are using it.
Yeah. Okay. Thank you.
Let me ask you one more question. The same question regarding question 1 of assignment 3. So there we are given some values regarding the reduction of body weight. So
Yeah.
So there the difference is given, no? The values showing the difference is given. So
Yeah.
you can see both positive and negative values in that. That means there was not only a reduction, but there was an increase because it is going two-way. If we got only plus values, if we got only minus values, then we would have concluded there is some point in saying that it is a one-tailed test. But here we have both positive values and negative values, and still we cannot say whether it is one-tailed or two-tailed. So that creates a confusion, no? It should be definitely two-tailed, no?
So
In
that
question
is
one,
not how you
assignment.
decide the. So ideally, that is not how you decide which test you should use. So before you get data, you should be clear on what test you want to use and why. So that should depend on your experimental design.
Okay, sir.
Right.
So we are actually comparing the two, no?
So in the
Still,
first line, we are sorry.
still
Continue.
that confusion. Maybe I don't know whether others have that confusion, but I was just asking out of curiosity that why cannot we have a benchmark to say whether it is a two-tailed test or a one-tailed test? Because we got both. When we see the difference, you can see both positive and negative values. So that means it's not going in one direction, no? That is what
So
makes me
that
confused.
is, yeah. So after seeing your data, you should not decide on what test you should use. Right. Ideally, before you do an experiment, you should decide what kind of test you are going to use. And after you get your data, you just run it through the test. So in the first line we are testing the effect of a drug to reduce body weight of rats with reference to an existing drug using the same rats. So since we are given that using the same rats, so they have thought of the experimental design as using the same rats and repeating the experiment with both the drugs. So we know we should use a paired t-test for this.
Okay, paired is
They would
okay.
have clearly
One-tailed or two-tailed?
paired is okay. Yeah. That is the confusion in this question. But I'm saying if they would have written that we want to check if new drug is better, if that is the line they should have added somewhere, they have just written we are testing the
Yeah.
effect, right? If they would have written we want to check if new drug is better, then we would have been clear that we are trying for a one-tailed test.
One-tailed.
But like,
In
don't be
fact,
confused that since the data is positive and negative, you will do a two-tailed test. The test does not depend on the data. Sometimes due to some other factors, you might see an increase or a decrease in the opposite direction in some of the samples. Maybe the experiment went wrong, or maybe the mouse had some different genetic makeup. That's why it, instead of like reducing the body weight, increased or something. That does not change what kind of test you are trying to do or you should do.
Okay. Okay, sir.
Yeah. Yeah.
Yeah. Okay. So, but still, that question is misleading, no? That is
Yeah,
still.
that question is kind of misleading. Yeah. Plus, like it falls in between somewhere. So, yeah, I'll talk to them about this. Yeah.
The
Okay.
other
So we'll
question
meet
also.
next week. Yeah.
Please take care of that decimal question. Okay.
Decimal question. Yeah. Yeah.
Okay. Thank you so much.
Okay. Yeah. Thanks. Okay. Bye.
Thank you, sir. Bye, sir.